Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Dr. Elena Hyde, and I'm joined tonight by the amazing Sana Withers, back again on York Universe. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or if you're listening live, that would be right now. We actually run in concert with the online public viewing program run by our amazing observatory team of undergraduate students, volunteers, co-op students, and more, running at this very same time, 9 to 10 p.m. local Toronto time. If you would like to follow along and listen to the show over with OPV, go on over to our website, yorku.ca/science/observatory, and follow the links to OPV for online public viewing, or click on any link that says YouTube. You can join in the chat. We've got a bunch of folks over there right now waiting to answer your questions, and of course show you beautiful images, either live or archival, of the skies. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please email us at observe@yorku.ca. You can always connect with us on Twitter at York Observatory or York Universe, and on Instagram at York U Observatory, and Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see that same website as before, yorku.ca/science/observatory. Our crew is, of course, monitoring the live chat now, so if you're live, feel free to join in. And, of course, we are monitoring the weather very, very carefully. It has been extremely rainy and windy and stormy today for a whatever this is. This is June 12th. Sana, I know it's been awful for you as well. It's just been absolutely drenching all day long.
Yep, same thing in Aurora. We just went from one kind of bad weather to a different kind of bad weather, and really haven't had any luck.
Well, it is a chance of clearing, I will say, later on tonight. The next few hours, some of those clouds might start clearing up in the Toronto area. It's not a promise, I did say might. So we'll give you some observing tips later on in the show. Of course, we have some nice bright objects, which are always helpful when you're dealing with clouds and sky that is not particularly clear. Of course, this did help the air quality a little bit in the Toronto area, so there are some good things to be had. We'll just have to play it by ear and see how it goes. Of course, weather is the really, if we had to say that there's a natural enemy for astronomers, it would probably have to be weather.
Yeah, it just never seems to cooperate with what we need. I swear, sometimes it feels like it's just spiting us, like, we pack up and leave, and then as we're leaving, it clears.
Yeah, and hopefully once we're finished with the robotic renovations at the Allan Carswell Observatory. So if you haven't heard, we are working on making it a little more robotic, and so that it can run itself after we leave. And hopefully that might help us catch a little bit more of these, shall I say, pockets of clearness that we keep looking for. There are a lot of good things to be viewing, so it's always nice to maximize your clear skies as much as possible.
Oh yeah, that'll be really nice.
And of course, clear skies have all kinds of uses. Not only are they good for telescopes, but they're also, I can get to Sana, your article, they're also quite good for launches, I hear. Launches into space, that is. So Sana, why don't we go over to This Week in Space and Astronomy History, and you can tell us about our first item for tonight.
Sure. So the first item does have to do with a space launch, which was on June 18th, 2009, the launch of two satellites, the Lunar Reconnaissance Orbiter, the LRO, or the Lunar Crater Observation and Sensing Satellite called LCROSS. So these were two NASA lunar satellites that launched together on June 18th, 2009, which actually marked the first time that NASA had sent any probes to the moon in over a span of about 10 years. I do believe other countries had been launching to the moon in this time span. It was just NASA, for some reason, had really slowed down and just hadn't been sending launches to the moon. Of course, they'd been doing other things within that time frame, but they'd kind of neglected the moon for a while. But these two satellites are completely awesome. The LRO in particular has produced some really amazing images. But anyways, both of the satellites had pretty similar goals when it came to studying the moon. They basically wanted to study the lunar environment and look for resources on the moon, which included water, as well as to help prepare for some upcoming missions, both including manned and unmanned missions, as well as the Artemis missions, of course, that are kind of ramping up a lot more now. So even though the two satellites had very similar mission goals, they went about things in two very different ways. So the Lunar Reconnaissance Orbiter, just as the name suggests, it was a lunar orbiter, and that's pretty much all it did. What the LRO has been able to do in its time in orbit around the moon is just completely awesome. So it produced at the time the highest resolution topological map of the moon that had ever been produced. To date, it's mapped about 98.2% of the surface of the moon with resolution of at least 100 meters. There are some areas that have been mapped in higher resolution, I believe down to about 50 meters, but it has mapped the entire thing, 98.2% of the moon, with this 100-meter resolution. The only areas of the moon that it was not able to map are actually regions that it just can't map because they're permanently shielded in sunlight. So this has definitely done a lot for lunar research, studying kind of the history of the moon, the surface, and also can help map out future landing sites for the Artemis missions or for any lunar rovers that are going to be touching down on the surface of the moon. One particularly cool thing that it's been able to do that I do want to mention, and people are kind of always surprised when I tell them about this, is that the high resolution images that it was able to take of the surface of the moon actually lets it see debris that was left behind by previous missions, including the Apollo missions. And this included tracks left behind by the moon buggies that astronauts used on Apollo, I think it was 15, 16, and 17, that they used to drive around the moon so that they could travel further distances than just walking. And it produced some actually pretty clear images of these tracks, given how small the tracks were on the surface of the moon. So all of these images are available online on NASA's website. So if you want to take a scroll through some really awesome lunar pictures, definitely look up the Lunar Reconnaissance Orbiter images. Moving on to LCROSS, which was a very different kind of mission. Instead of being a lunar orbiter like the LRO, it was actually meant to be an impact satellite. So it was launched with two different components, the LCROSS itself and then an upper stage that was attached to LCROSS, where what was going to happen is that the upper stage would detach from LCROSS, impact an area of the moon that was completely shielded in sunlight, so couldn't be observed by satellites like the Lunar Reconnaissance Orbiter. In doing so, it would eject a ton of stuff into space. LCROSS would fly through it and analyze the composition of the dust and other stuff that was kicked up by the upper stage, send that back to the Earth so that it could be sort of investigated and learn about the actual composition of the soil on the lunar surface. And this is exactly what happened only a couple of months after the launch on October 9th, 2009. The upper stage impacted a crater in a permanently shielded area. It kicked up about 350 metric tons of material in the process, making a crater that was a few hundred meters in diameter, which then LCROSS then flew through and analyzed the dust. So the two missions have really, especially when combined, have done a lot in terms of lunar science. They've been used to confirm the existence of water ice on the surface of the moon, and also to confirm the existence of many other kinds of materials and composition of the lunar surface. The LRO in particular has also made it possible to kind of scope out some other areas, which will be very, very useful for the Artemis mission. So the impact of the upper stage of L-Cross kind of marked the end of that satellite's lifetime in lunar orbit. It actually ended up impacting the moon itself a little bit later on because that was really the point of the mission. It wasn't really designed to do anything else. But the Lunar Reconnaissance Orbiter is still active and will continue to be active until later in the 2020s when it runs out of fuel. So NASA's pretty much just planning on using this thing until it dies. But these are definitely two really awesome missions, which launched June 18th, 2009.
They're very, very awesome missions. And of course, we talk about some of the difficulties that we have in planetary studies in the solar system. It's really, really hard to get things from other planets or bodies to Earth. And so this was a really unique kind of imaginative way of solving that problem by having material ejected off of the moon, right? That could then be analyzed. And we were talking before the show started about more of this, please, right? Let's have more of this where we can have these remote missions that could go and potentially collect material. Well, this is from the moon, but there are a lot of very, very interesting things in our solar system that we have never touched, and we have no idea what they're really, well, some idea, but no, like no detailed idea about what their composition really is like. And of course, with the giant plume from Enceladus being spotted by JWST, we've talked about that. I think we have talked about that before. But yeah, you could use the same idea, right? You could literally just fly through it. It's so tempting. Let's do it.
Yeah, and like a lot of these satellite missions going to visit other planets, they kind of show you like you have to go there to really learn about something, especially objects in our solar system. There's always surprises, no matter how much you think you know.
Yeah, and I mean, it doesn't get closer to Earth. Well, fortunately, it doesn't get much closer to Earth than the literal moon.
Yeah.
And it took us this long and this level of technology just to get solid, firm confirmation of water ice on the closest thing to us. So it's just it really is it just shows how much you can do with these missions and how much there still is to do, which is always really, really exciting. And of course, I just have to give, as you say, a little shout out to the LRO, the Lunar Reconnaissance Orbiter, because it's not just done maps. It's actually done its own little whole set of discoveries. And some of you may remember last year there was kind of a controversy about a mystery object hurtling towards the moon, which left a crater in 2022 in March, I believe. And it was actually spotted. Yeah, it was actually spotted with the LRO. And because we had the Lunar Reconnaissance Orbiter out there photographing the moon since 2009, we actually know exactly where that rocket crashed. And they did eventually confirm it was a rocket body. So, but it made quite a splash last year because it's like, oh, somebody's throwing things at the moon. It was just a rocket body, but it actually made a bit of a double crater when it impacted. And it's a really unexpected outcome. So a lot of people who study craters and geology were kind of surprised about the way that this crater took shape. And there's a lot of fun, interesting things you can do to try to make crater shapes in your kitchen with flour and rocks and clean up afterwards. But
maybe best to do that in the backyard.
Yeah, in the backyard, maybe outside of the kitchen, maybe an option as well. But having this double crater unexpected shape, meant that the impactor itself had to have had a certain shape. And it was actually one of the keys to identifying the rocket body that was the cause of the crater. So it's really cool. And they took a there was a whole thing last year. We won't go over it again in this show. But of course, some people in the U.S. said it was from China. China said it's not ours. SpaceX said it's not ours. And there's been some analysis that seems to indicate that due to the crater shape it left, the shape that it would have had matches a rocket body of the Chang'e 5T1. So it's interesting.
Yeah.
It's like, oh, okay, we can actually figure out where this came from, and it's all thanks to the LRO, and I hope they do just leave it running for as long as possible. Mm-hmm. And when it makes its own crater, we can
yeah,
we'll send a new one to analyze that crater.
Yeah.
But yeah, hooray for the moon. Very excited for, of course, more Artemis. I hope next year goes well in that respect. And it just goes to show that there's so much to do in our own solar system still, even just on the closest thing to Earth. It's our literal moon. And so when you think about things farther away than the moon, or farther away than the icy edge of our own outer solar system, you can kind of get an idea that this might be many, many, many orders of magnitude harder to get detailed information from. And so I think that's what I'll use to get us to my This Week in Astronomy History, which is actually a planet that is not going around our own star, but a planet going around star Gliese 876. So this is going back to 2005. So we're not going super far back in history, but on June 13th in 2005, a third planet orbiting the red dwarf star Gliese 876 was announced. And this was an exciting announcement because in 2005, there weren't actually very many planets outside of our own solar system known. And if you've listened to this before, you know that when we talk about history, it was actually a long time before a planet outside of our own solar system could be proven and, measured and shown to exist beyond the shadow of a doubt. So that took a long, long time for humans to ever really solidly discover that and measure it. And by 2005, we had some exoplanets, but not a lot. So it was kind of each new exoplanet was, wow, okay, that's possible too. So this was a third planet orbiting a red dwarf star, smaller, redder, more flary, going to live for longer than our own sun. And it already had 3 planets. So this was number 3. So it already had 2. This was number 3. And this was a mass at 7.5 times that of Earth. So it could be rocky in composition. It orbited at 0.021 AU. So Earth is at 1 AU from our own sun. 0.021 AU is close to that star. And it had a period of 1.94 days. So it was going around the star at a pretty close distance. So we had something that was bigger than Earth mass-wise, but it could still be rocky. And it was close enough to its star that it was going to be getting a lot of heat. So this kind of a more rocky, more Earth-like planet was really, really interesting. So 876D is the official name of the exoplanet. And this actually gets you a little bit into a little bit exoplanet history as well, because A is a star, and then you have B, C, D. So the third planet is D, which is super confusing. So if you've ever wondered why astronomers are so bad at naming things, I don't know, but I've always found that to be a very, very confusing bit of exoplanet nomenclature. So, if you're looking for this particular star, the red dwarf Gliese 876 is about 15 light years away. So it's not an incredible distance like some of the things we talk about in this show. It's got an apparent magnitude of around 5, so you could find it with good binoculars, I suppose. I'm not sure if it would be naked eye, certainly not from Toronto tonight. But the red dwarf star is about 15 light years away from Earth. It's in the constellation of Aquarius, and it's one of the closest known stars to the sun. So the fact that it has a planetary system with 3 planets as of the discovery of D, they talk of a 4th planet is I think there's some evidence. I'm not sure how far along they got with the 4th planet evidence if they've fully pinned down its entire orbit. They do think that the 4th planet E would have a mass of around more like 15 masses of Earth, which is a little bit different. So, anyways, it's a really interesting star, close to the sun. Different from our sun because, of course, red stars are cooler. Our own sun is a G-type star, which is a yellowy star, which is going to, of course, last for many, many more years to come. So the smaller the star, the longer they live, the cooler they burn. So it's not going to be as luminous, but it will be able to give plenty of energy to anything that's close to it. And the planets that were found were fairly close, short periods, close to the star. It is a variable star, and one of the things as red dwarfs, they tend to be able to have flares or variation, and it can be a little bit unpleasant if your star is doing big changes in its luminosity, at least if you want to do anything stable on the surface. So it's been a really fun planet or system, a really fun planetary system for quite a while. So its first planet was announced back in 1998, and this was one of these really exciting ones. Like, hey, we found a planet just 15 light years away. So it's been a really fun investigation, and as the years have gone on, we found more and more and more exoplanets. Finally, of course, with Kepler. We had a huge boom in exoplanets the last few years. And in 2023, if you just look for exoplanets from only 2023, you'll have to scroll for quite a while. They've continually finding more of them, and of course using mathematical models to fit to old Kepler data. They're still doing pretty well by looking for, but we do need more exoplanet missions for sure. Of course, this particular planet that we're calling out for today, this was just planet number 3, and it was discovered in back in, I should say, 2005. So at the time, it was a bit of a rarity, a bit of a unique one. Having it be more towards the mass of Earth and less towards the mass of Jupiter was also a somewhat unique phenomenon. Jupiter masses are bigger, and bigger is easier to find. It's a lot easier to find things that are a few times the size of Jupiter than a few times the size of Earth. So, of course, somewhat of a observational bias, a lot of Jupiter things were found and not very many Earth things. So that's also changed in the last few years. But this particular planet D, coming from radial velocity, it can only give you a lower limit on the mass because, of course, your orbital inclination is not quite known. So they've done a bit of modeling, and they think they've got it pinned down, but you have to take a lot of the estimates with some error bars, because, of course, if you can imagine in space, you've got planets going around their stars, and even if your orbit is in a circle, well, a circle turned on its edge will turn into a line. So you could have any kind of inclination which makes it very, very hard to make an accurate estimate. So your masses, when you use your, well, even if you just use Newtonian physics, your masses will still just be a lower limit. All right, so really fun planet close to its star. And they actually think that this unusual system of this red star with the planet quite close, it might have actually formed far away from a star and migrated it inwards. And because, of course, this whole system is very different from what we see in our solar system, the question that people were all asking themselves was, how did it get that way? So how did it get into an orbit of only 0.0208 AU, which is a tiny, tiny fraction of the distance from the Earth to our sun. And that tiny fraction, if you want the real number, it's 3.11 million kilometers. So at that distance from a star, tidal interactions should, in theory, circularize the orbit, but it was actually found to have an eccentricity comparable to that of Mercury in our own solar system. So it's been a really, really fun planet for a lot of people to play with. I think Gliese 876 is still one of the more popular exoplanet systems to target, especially for student projects. So students, I'm sorry if you've gotten assigned this one, or maybe not. I'm not sorry. It's a wonderful system. So I'll just go ahead and say exoplanets, really, really fun. And back in 2005, it was just kicking off, and in particular, just kicking off for more of the rocky type exoplanets that get us towards, if not other Earths, then more Earth-like than Jupiter's. So back in 2005, good job, old astronomers from 2005. Not to say that you're old if you were doing astronomy in 2005. That would just mean me too. So, 2005 seems like it wasn't that long ago, and then I look at the date and I realize, it was a while ago. So that's what happens, folks. So getting out of the solar system is fun, but I think we'll go back towards the inner solar system for the next this week object.
Yeah, this is actually technically about leaving the solar system too. So,
so how long would it take us to get out, Sana?
The answer is it depends, but either way, a very long time. So this Week in History item is about when Pioneer 10 has been considered to leave the solar system. And it turns out there is more than one way that you could consider something having left the solar system. So this one, I'll explain a little bit more which particular definition this one used. But basically, the Pioneer 10 mission was a NASA mission with a twin spacecraft, Pioneer 11. And these Pioneer 10 and 11 missions were really groundbreaking missions that have done something it's actually pretty common now going to the outer solar system, but back in, 1983 and before that, it had never really been done before. So Pioneer 10 was a spacecraft that had a lot of firsts in terms of solar system exploration because it was the first of its kind. There were a lot of different things, which included it being the first spacecraft to fly past Mars, go through the asteroid belt, and visit in part the planet Jupiter. And all of these were pretty big milestones at the time, especially the going through the asteroid belt part was pretty significant because we didn't really, or astronomers at the time didn't know if something could actually successfully make its way through the asteroid belt. There's of course a lot of asteroids in the asteroid belt, some very big, and there was always the possibility that if there were a lot of really huge asteroids in the asteroid belt, that spacecraft would not be able to get through. They would just collide with some massive asteroid, and then that would be the end of the mission. But Pioneer 10 sort of showed that it actually is possible to get through the asteroid belt without colliding with something and killing the spacecraft, which ended up allowing NASA and other space agencies in collaboration with NASA to launch a lot of missions into the outer solar system. But among all of the firsts that Pioneer 10 has, that's most relevant to this one, is that it was able to cross the orbit of Neptune, which in this case, NASA and everybody else is considering Pioneer 10 to have left the solar system at the point that it crossed Neptune's orbit. For reference, this is a distance of about 30 astronomical units. So we're, like mentioned before, 1 astronomical unit is the distance between the Earth and the Sun. So it's about 30 times that distance. You can also define exiting the solar system in terms of the boundary called the heliopause, which is where the kind of the boundary between where solar wind has an influence on things and where the other interstellar wind in our galaxy has an influence on its surroundings. So it's kind of just the end of where solar wind is able to influence things, and it changes off into to interstellar wind, which happens at a distance of about 123 astronomical units. But anyways, Pioneer 10 crossed the orbit of Neptune, so left the solar system on June 13th, 1983, after having crossed through the asteroid belt and visited Jupiter, and really did a lot of things that had just never been done before in terms of solar system exploration. That did not mark the end of the mission, however, and it continued taking data on things like solar wind up until March 31st, 1997, which was when NASA ceased regular contact with the spacecraft. It continued communicating with the Earth, just less frequently, until January 23rd, 2003, which was 20 years after it had left the solar system. So it stayed on for quite a long time. And currently, right now, it is headed in the direction of the star Aldebaran in Taurus. And if it does reach Taurus, it would be in about 2 million years. So it's taking a very, very long time to get there. At this point in time, it's also around 132 astronomical units away from the Earth, which, if you recall from the number I gave earlier, is about 10 astronomical units further away than the heliopause. So regardless of how you define what it means to leave the solar system, Pioneer 10 has definitely left the solar system and has become one of only 4 spacecraft that have ever actually left our solar system, which the other 3 are Voyagers 1 and 2, and then Pioneer 10's twin spacecraft, Pioneer 11. And New Horizons, the New Horizons spacecraft as well, will eventually leave our solar system by crossing the heliopause. Just have to give it a little bit more time. But yeah, that was the anniversary of the very first man-made object to leave our solar system, Pioneer 10.
Yeah, and of course, that's what it does take. Many, many decades of going very, very, very fast, and it's still going to be absolutely ages before they get anywhere. And just as a little call out, if by any chance any of those had actually been aimed the right direction to go to the closest star to the sun, the Proxima Centauri, that is still 4.2 some light years away. So it would still be a very long time.
Yep. And at the time, Pioneer 10 was actually the fastest thing to have ever been launched off of the Earth. So it was traveling very, very quickly, and it still took decades for it to reach the get out of our solar system.
Yeah, and that's it. The distances in space are called mind-boggling for a reason. It's very hard to picture the amount of emptiness that is out there. And that was one of the things that I think if you draw it out mathematically, it would make sense that there would be no chance of asteroids in the asteroid belt hitting you. But when you picture all the asteroids that are out there, if you tell people the huge number of asteroids and that they're in the way, we can't conceptualize of how much other space is also out there. And so we picture them closer together. And that's, you see it in science fiction quite a lot in Star Wars, or, flying your spaceship through the asteroid field and you're dodging left and you're dodging right. And in the asteroid field is just emptiness. It's emptiness, and you're going and you're going and you're going, and way off in the distance a little rock floats by somewhere, maybe. Like, that's the amount of space in space is tremendous. And I'll just say as well, if it had made it to, if it had been going the direction of Proxima Centauri, it would still be a very, very long time before it got there. But Proxima Centauri itself, the closest star to the sun, is actually finally known to have planets now. And the surprising thing is it took so long to find these planets. It has one really solid planet that's been confirmed and one candidate that they're waiting to confirm. And as I say, because his star is A, the planets are Proxima Centauri, B, D, and the disputed C. And I think B and D are now fully confirmed. And B orbits the star at 0.05 AU, so very close. And its mass is about 1.07 times that of Earth. So the low mass, Earth-like mass, prevented us from seeing planets around literally the closest star to us. So our next door neighbors of the same size planet as Earth, we couldn't see them for a long time, actually. So it was, and it's always been one of the things I found so surprising in in astronomy, really, is that Proxima Centauri in the Centauri system, we don't do more for it, being that it is so close to us. And it's, of course, now it is confirmed. So Proxima B was announced in 2016. It took several years to fully confirm it. And they actually ruled out larger, much larger than Earth exoplanets in the habitable zone back in 2008 and 2009. And, they were trying all the way through 2016 to find out, what was going on, but it was only in 2022 that they actually got Proxima Centauri D. So these are, closer in size to Earth, literally around the next star over, and it took us so long to find these planets. And of course, as you mentioned, Sana, it would also take a really, really long time to get there.
Yeah, it's crazy how long it takes to confirm some of these exoplanets, but I guess if you think about it, it makes sense because of how tiny these are compared to the star.
Yeah, and that's exactly right. The signal through the noise, right?
Yeah,
it's there's a lot of noise out there, and if you're going to say that you have an exoplanet, you've got to be very sure that it really is an exoplanet and not some tiny mathematical effect you forgot to take account of.
Mm-hmm.
All right, so before we go on any further through space and time and planets, let me go ahead and just remind everyone. You are, in fact, listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our crew right now is over on the OPV, or online public viewing chat on our YouTube. You can get there by going to yorku.ca/science/observatory and clicking on OPV, or going to any link that says YouTube and clicking on that. It'll take you directly over. They're live with us, so if you're listening live, head on over now. Of course, we're also on Twitter at York Observatory and York Universe. And tonight, you're listening to myself, Dr. Elena Hyde, and Sana. We're discussing all kinds of things, how other planets, how to get to them. It's going to take a while. And basically lots of interesting things out there in space. They just happen to be also very far away from us. All right, so we've got one more quick little this week in space and astronomy history. So I wanted to give a final shout out to an interesting exoplanet. So this is just a selection. Of course, there are so many amazing systems right now. If you want to know more, go look up Kepler exoplanets. But back in 2010, on June 10th, Beta Pictoris b was the first time the very first time astronomers were ever able to directly follow the motion of an exoplanet as it moves to the other side of its host star. So Beta Pictoris b has the smallest orbit of any, so far that I know, any of the directly imaged exoplanets. It's as close to its host star as Saturn is to our sun. So if you're going to directly image an exoplanet, it has to be able to reflect enough light from its star for you to see, and it has to be far enough away from its star for you to resolve it. So usually to directly image a planet, it would have to be very, very far from its host star. That would completely rule out directly imaging Earth-type planets. Out of the question. They're too small, they're too close to their star. But Beta Pictoris b, it showed us an interesting exoplanet orbiting a young debris disk A-type main sequence star, Beta Pictoris. It's about 63 light years away, so a little bit farther out. And it had a mass of 13 Jupiter masses, which is a lot, but it's not so bad. It's still massive, but it's not a binary system. It's a super Jupiter. And it was about as far away from its star as Saturn is from our own star. So this is an interesting exoplanet, and being the first sort of direct image, it has some lovely some lovely pictures you can find. It orbits its host star every 21 years at a distance of 9.2 AU. It receives about 11% of the sunlight that Earth does from the sun. So it's not getting as much heating from its star. Of course, being out at 9.2 AU, that would be 9 times, or about a little more than 9 times farther than the Earth from the sun, so getting less sunlight. And of course, the star itself is a little bit different. Beta Pictoris is in the constellation Pictor, and it's about 1.75 times as massive and about 8.7 times as luminous as the sun. So it's not a direct analog. It's still it's getting less sunlight, not as much sunlight. It's got a rotation period that's been calculated, and they were actually able to look at the broadening of carbon monoxide infrared absorption lines to get its rotation period. So it's one of the, I believe it's still one of the only extrasolar planets to have had its rotation rate measured, because these things are so incredibly far away. The angle that they subtend on the sky is absolutely tiny. And of course, lots and lots and lots of follow-up has been done over the years on this. So it's a really fun little exoplanet. So I just wanted to go ahead and round off with that one for our This Week in Space and Astronomy history. And we do have some reminders as well. So, of course, we're talking about Beta Pictoris b being as close to its host star as Saturn is to the sun. Well, the sun is down right now in Toronto, thank goodness, finally. But Saturn, Saturn's sort of following around the sun, but it's not totally impossible to view. Sana, I think you have some observing tips.
Yeah, there's a couple of very interesting, I guess, conjunctions is probably might not be the right word, but kind of close passes between some things in the solar system this week. So tonight and tomorrow night, I think you probably missed your opportunity tonight because it is a little bit late now. But tomorrow night, if you look in the direction of Venus, it's actually going to be very close to what's called the Beehive cluster at Messier 44. So that's an open cluster in the constellation Cancer. It is pretty bright and easy to see if you are willing to do a bit of star hopping with a star chart. And you don't actually need a lot of telescope power to be able to see it. You can even just use a small pair of binoculars. But the interesting thing that's happening with M44 in the next couple days is Venus is going to be very close to it. It's going to be less than 1 degree away. So this is a nice little close approach between the two that should make for some very interesting viewing with bright Venus and bright Messier 44 together. And then over the next 3 days, on the 13th, 14th, and 15th, Jupiter and the moon are going to be pretty close together in the sky as well. So on the 14th in particular, it's going to be a crescent moon right next to a very bright Jupiter about an hour or so before sunrise, which is, again, a very easy thing to see because you don't actually need any telescopes for this. The moon and Jupiter are both very bright, and you should be able to see them without any kind of problem. So a couple very interesting observing events coming up this week if we could only get some clear skies.
Yeah, absolutely. And actually, I just will give a shout out to anyone who is listening live right now. Venus is at about 22 degrees altitude and setting in the west. It's very bright. If you have a clear spot, you might be able to catch it as long as there's no big giant buildings in your way. And it is absolutely lovely. So you have a wonderful chance to catch it. And if you're out watching the sky, it's been an interesting couple of days because we do have a nice, as I mentioned, a nice alignment sort of chaining across the sky at the moment. You have, of course, Mars and Venus following the sun down. But we actually have Mercury and Jupiter and the moon up as well. So you have across the sky, Saturn, moon, Jupiter, Mercury, sun, and then, of course, Venus and Mars. And so as the sun sets, you get your good chance to view Venus and Mars. And before the sun rises, you get your good chance to view Saturn, and Jupiter, and of course the crescent moon, and if you're really, really lucky with your horizon, a little bit of Mercury. So it's actually, yeah, a great time for viewing, just not weather-wise.
That's always how it works.
Tisk tisk. Such is the way of astronomy. So we'll go ahead and just have one extra reminder this week. This is the June 12th. So on June 14th, it is the Wednesday, we will be playing a special game of Astronomicers over on the YouTube channel at 7:30 p.m., which you will be able to play along with. So the idea, of course, is that one of the team members on the YouTube video will get a secret word and a list of words they're not allowed to say, and they will have to describe it such that someone is able to guess what they're saying. It's very fun because you cannot use the words you want to describe the things. And so it always makes for a pretty good time. So if you would like to join us on this Wednesday, that's 7:30 p.m., it will be one of our official Teletube YouTube episodes. And those are fortunately weather independent. So I think that's all the announcements we have for, or reminders, I suppose we have. You have anything else, Sana?
Nope, that's it, I think.
All right, well, let's go ahead and look into some news items. There's some very, very exciting ones. Of course, I obviously have one about exoplanets, but let's talk a little bit about jades, because that is something that I think more people need to know about. So, Sana, why don't you take us away?
Yeah, so JADES is this really awesome JWST observing program that's been going on for quite some time, and they're actually still getting more data coming up. But it's they get a total of 32 days of observing time with the James Webb Space Telescope, which is a lot more than most other programs. I believe this is one of the biggest ones currently running in Webb's first year of observations. And basically what they're doing and what the goal of JADES is overall is to just study galaxies and galaxy evolution, especially in the distant universe. So on Monday of last week, they got enough data and decided to do a data release. So they made a lot of their data and their catalogs public, so astronomers, other astronomers who are not part of the collaboration can start playing with it. This also came along with some very pretty pictures, high-resolution images of the night sky with thousands of galaxies in it, and some very interesting science papers. I'm pretty sure they must have published like 10 science papers from JADES in like one day. So whatever your interest is in galaxies, they definitely have some new interesting science to go along with it. But basically what JADES is doing and what this data release is is its observations of the Hubble Ultra Deep Field and the GOODS South Field, where GOODS is an acronym. It just stands for the Great Observatory's Origin Deep Survey in the South Field. They have a North Field as well, but this one in particular was dealing with the GOODS South Field. And the reason why these patches of sky for the Hubble Ultra Deep Field and GOODS are so awesome is because they have a lot of really good observations from other observatories, from most major observatories actually, which include NASA's four great observatories: the Hubble Space Telescope, the Spitzer Infrared Telescope, Chandra X-ray Observatory, and the Compton Gamma Ray Observatory. So it was kind of a natural idea to follow up these areas with Webb to sort of expand on the data that's available in these fields and do a lot of really cool science. So there's already been a lot of very interesting things that have come out of JADES over the past year almost, because it is almost a year since Webb's began its science operations and released its first data set. Actually, a month to the day. It was July 12th that happened, but we'll leave that for this week in space and astronomy history for whoever's on in July. But once they started taking data, they just started releasing a lot of really cool stuff. And with the data release and all the papers that they published on Monday, it was kind of a natural thing to talk about JADES today. So included in some of this data release was the discovery of about 1,000 or so galaxies, 717 in particular, which are very, very distant galaxies, and 93% of which are newly discovered. So these hundreds of galaxies that were found in the JADES observations are pretty significant because they exist in a period of time called the epoch of reionization. This happened within roughly the first billion years of the universe's history, where it transitioned from being mostly filled with neutral hydrogen, which made it opaque when you can't see through it, to being mostly transparent and filled with ionized hydrogen. So you could start to kind of see through these clouds of neutral hydrogen as the first galaxies started turning on stars. It ionized all of the gas that surrounded it and made it transparent. And this is a very important step in the history of our universe, even though it only took a few million years to occur. And keep in mind that the universe is 13.8 billion years old. So this is a relatively small time span that we're looking at, but it definitely was a very important time period, in part because it was when the first galaxies in the universe were turning on for the first time and starting to form stars. So the galaxies that exist in this era look very different from the galaxies that we're used to more locally and close to us. And it's been a goal of astronomers for quite a few years to study galaxies in this era, and you really do need Webb for that because of how sensitive it is and because it's an infrared telescope. So in the past, galaxies in the epoch of reionization that had been identified were really only the brightest and the most extreme galaxies that existed in that time. But with JADES and using the power of Webb, they were able to identify a lot more normal galaxies that existed during that time period, which lets them study what these normal galaxies were, how this process of reionization, moving from neutral to ionized hydrogen, how that happened over billions of years, and how galaxies assembled and formed stars in the early universe. So among some of their many interesting results, they were studying in particular, how galaxies assemble and form up their stars in the epoch of reionization. And one pretty interesting result that they came out of this is that star formation is very bursty in the epoch of reionization, meaning that instead of slowly forming stars over longer periods of time, galaxies undergo these really intense bursts of star formation, form a ton of stars, and then that's followed by a bit of a lull where they don't do much star formation. And then sometimes that just picks back up again later on and forms another load of stars in a quick burst and then lulls again, which is definitely an interesting discovery. They were also using some of the JADES data to study the epoch of reionization and how exactly that proceeded. And they were able to make some studies of ionized bubbles that existed around galaxies and were embedded in a lot of neutral hydrogen. So it's kind of like the early universe. You can imagine it sort of looked like Swiss cheese almost, where you have these bubbles of ionized hydrogen surrounded by bubbles of neutral hydrogen. And for the first time, we're able to make some studies directly of those ionized bubbles, which is definitely very interesting. So there was, definitely a ton of science that came out of this within the first data release. But now that it's also available to the community, there's going to be a lot more to come out of this when everybody else starts playing with it. And if you want to play with the data as well, you don't have to be a scientist to do that. You can definitely look at all the pretty pictures that were produced from JADES, and they even have this cool little viewer. If you just Google JADES JWST image viewer, it should come up, where you can zoom in on high resolution images of the galaxies, and if you click the right buttons, it will even tell you properties of the galaxies if you're interested in, like me, wasting a lot of time zooming all the way in on images and looking at cool things.
Absolutely. And who doesn't love beautiful images of galaxies?
Yeah, there's definitely a lot of really cool ones in the JADES images.
Yeah, and this is something that, of course, JWST is doing so many different things at the moment. Sometimes we forget that they're also, yes, they're doing extragalactic. Yes, they're imaging plumes off Enceladus. And of course, earlier this year, there was even an exoplanet found with JWST.
Mm-hmm.
So it really is just doing so many things that we wouldn't even have guessed before its launch. And that's exactly what we wanted, really. Just lots of fun, amazing new stuff that we didn't know was there before.
Yeah, it's always interesting looking at the new papers that come out every day with JWST. There's always something interesting. Every single day, there's something JWST related coming out.
It's got something for everyone. This.
Oh yeah.
And unfortunately, I'm not going to talk about the exoplanet from JWST. But it was earlier this year, so if you want to look it up, I recommend it. I will keep my news article fairly brief. I just wanted to let people know that in the news right now, there is a new exoplanet that you're going to hear about, which is called Bebop 1c. It's the second ever known planetary system orbiting twin stars. So, of course, you might hear about this in the news and coming up as like the Tatooine-like exoplanet, because of course it's a binary system. And this is a fun one because over half of all stars in our galaxy are binary or more. But we haven't found a lot of planets in binary systems. And a lot of that is due to the fact that they're just very, very, very hard to find. We talked about some of the difficulties before in teasing out the signal. Well, a lot of exoplanets candidates, before they get confirmed, people find out, oh, it's actually just a binary star. It's not really an exoplanet. So that can be one of the false detections that you get. And having it be a binary makes it a little bit more challenging. So this new exoplanet was discovered by astronomers from the University of Montreal, and they think that it's potentially even got volcanoes. So the idea behind, you'll hear people saying potentially volcanoes. Well, the binary system itself will provide some kind of tidal heating to anything that's in orbit if it's close enough. So this Bebop 1c is the second ever known planetary system that is orbiting twin stars. And it is, unusual, but not so unusual. It's more the case that they are hard to find rather than that they probably don't exist. So with about 15 circumbinary planets out of over about 5,200 so far or more and counting, it's pretty exciting. So it is an exciting new exoplanet out there. This one's about 65 times the mass of Earth, Bebop 1c. So, don't get too excited about it being something you could walk around on. So in case you hear about the Tatooine planet, it's not actually something that probably you could walk on. And I think we'll go ahead and have a final thought for all of our different planets that we haven't gotten to talk about today. We didn't even get to mention TESS, so my apologies to any TESS fans out there in the audience. Maybe next time.
Yeah, lots of very cool different exoplanets. It always surprises me the cool things and the weird things that they find on different exoplanets.
Yeah, and in very, very different locations than our own solar system. So as far as we can tell so far, our solar system isn't necessarily typical, but our statistics are awful, so who knows? All right, so on that note, on that happy note, let's go ahead and thank everyone once again, and just say, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana Withers and myself, Dr. Elena Hyde. Stay tuned because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter, Instagram, or Facebook, and check out our website for show notes and content, yorku.ca/science/observatory. Thanks for tuning in, everyone. Clear skies, and have a good night.
Have a good night.
Really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm.